Okay, so now we know that the flow of the electricity is going to be called the electric current. The thing that is going to be pushing the electricity through the wire is going to be a voltage, and then the thing that's going to be slowing down the flow of the electricity is going to be the electrical resistance. So those are our three quantities. And so now we want to put them together. And so I'm just going to show you this formula over here for the flow of water. But again, do not worry about it. It's not going to be on the exam. But it turns out that the pressure is the thing that causes the water to flow. And so the R is the resistance to the flow, and then the flow itself is the volume flow rate. So that would be this thing here. So that's what you would learn if you were talking about fluids. This is an equation that allows you to calculate the amount of pressure that would be necessary in order to cause a certain flow rate. But we're interested in electricity. So what is the pusher of electricity? So that's going to be the voltage. So we have the voltage is going to be equal to, okay, now this is going to be the resistance, but this is the electrical resistance. And then finally we got the thing that is flowing, which is the electrical current. Now, normally we don't write it this way. We say that V equals IR. That's the way that it's normally written, and that's going to be called Ohm's Law. And guess who came up with that formula? Mr. Ohm. So the same guy who's got a unit named after him, he was the one that came up with this formula. So this relates the voltage in a system to the current in the system to the resistance of the system. Now, again, do not worry about this as far as the test is concerned, but if you know anything about pushing objects, you know that you push it with a force. So a force, you apply it to a, let's say you're trying to move a piano, and you can move it. So when Newton's second law of motion says that force equals ma. And so A is the movement of the piano. So that's kind of similar to the current. And then M is called the inertia. So that a larger object is going to have more inertia than a smaller object. So that piano is going to be really hard to get going because it has a very large M. So similarly, this is electrical resistance, which is the resistance to the flow of the electricity. So kind of interesting, very similar looking formulas, but just let it ooze out of your head. There it goes. Doesn't that feel so much better? All right. So I couldn't help myself. Thought you'd find that kind of interesting. So we're going to concentrate on this. V equals IR. Doesn't make any difference whether you call it R times I or I times R. It's going to be the same thing. So here is a word problem. A 6-volt battery is connected to a resistor. A 2 amps of current flows through it. What was the resistance of the resistor? So you always begin by writing down what you know. So it said a 6-volt battery. So volts goes with voltage. So we know that the voltage was the 6 volts. Then it says 2 amps of current. So amps goes with current. So therefore I is equal to 2 amps. And we want to know what's its resistance. So we're looking for the letter R. So we're going to select the formula that connects the letters. And so I I'm writing V equals IR because that's the standard way of writing Ohm's law. And then plug in your numbers and then do algebra on it, and you end up with a resistance of 3. And then don't forget to put the unit on the end of it. So put the ohm on the end of it. All right, let's take a break. When we come back, we will talk about electrical power.